Let's talk about Jupiter, the undisputed king of our solar system. For a long time, we thought we had it all figured out, but some recent discoveries have completely flipped the script on everything we thought we knew.
And I mean, this quote really says it all. The image you probably have in your head from school, the big stripy gas giant, is fundamentally wrong. It's totally outdated. So here it is, the big reveal. Jupiter is not a giant ball of gas. It's a liquid planet. And if that wasn't weird enough for you, it's a liquid metal planet. So let's peel back the layers and see what's really going on in there.
First, let's just rewind a bit to what we used to think. For centuries, the biggest puzzle about Jupiter was its sheer size. I mean, it's a scale that's genuinely hard to wrap your head around.
This little comparison helps a lot. If our planet, Earth, was the size of a single grape, Jupiter would be a full-sized basketball. The difference is just staggering. And to put a number on it, you could cram about 1,000 Earths inside of Jupiter. It's heavier than all the other planets in our solar system combined. So you have to ask, how could something this massive even form?
Well, for a long time, there were two main ideas on the table. The first one, the solid core theory, is pretty straightforward. A huge rock and metal core forms first, and then its insane gravity just sucks in all the gas around it. The other idea was that a giant cloud of gas just collapsed in on itself, kind of like how a small star is born. Now, that solid core theory is the one most of us were taught, but as we're about to see, reality is so much stranger.
So our first huge breakthrough actually came from this incredible, once-in-a-lifetime cosmic coincidence back in the mid-90s. The timing was just perfect, and it gave us our first real peek inside this giant planet.
You honestly can't make this up. In July of 1995, a comet, Shoemaker-Levy 9, slammed into Jupiter. This kind of thing only happens maybe once every 6,000 years. The only problem? It hit the far side, so we couldn't see it from Earth. But, and this is the crazy part, at that exact same time, NASA's Galileo probe was on its final approach to the planet, giving it a perfect front-row seat to the whole show, before it even officially arrived to study the aftermath. What are the odds?
And the scale of this collision was just mind-blowing. The single largest piece of that comet hit with the force of 300 million atomic bombs. It was, hands down, the biggest explosion humanity had ever recorded.
So when Galileo finally got there, it flew right through the debris clouds that were kicked up from the impact. This was literally our first sample of what's inside Jupiter. And what did it find? A ton of water. This was a complete surprise, and it was so weird that it basically forced scientists to plan a whole new mission, which they called Juno, just to figure out what was really going on inside this planet.
Okay, so now let's take that journey ourselves. Using all the amazing data from Juno and Galileo, we're going to descend through the layers of this bizarre alien world, right from the clouds we can see all the way down to its mysterious core.
All right, we start at the top, in the layer we all recognize, those beautiful, swirling, and incredibly violent clouds of ammonia.
What's surprising is that this layer is actually super thin, only about 50 kilometers deep. It's absolutely freezing, well below negative 100 degrees Celsius, and it's home to these unbelievably gigantic lightning storms. And that famous Great Red Spot? Yeah, that's a storm wider than our entire planet that plunges hundreds of kilometers deep into the atmosphere.
But once we go down about 1,000 kilometers below those clouds, things start getting really, really weird. The gas becomes a liquid, and we find ourselves in an ocean of hydrogen.
The physics here are just nuts. This is the largest ocean in the entire solar system, and it's about 20,000 kilometers deep. And get this, even though the temperature is over 1,000 degrees Celsius, the crushing pressure from all that gravity is so immense that it forces the hydrogen to stay in a liquid state. It's literally an ocean of super hot liquid. And if we go even deeper, the pressure becomes so extreme that the hydrogen transforms into something else, something exotic. We've now reached the largest part of Jupiter, a sea of metallic hydrogen. So what on earth is metallic hydrogen? Well, it's this really exotic state of matter where hydrogen is still a liquid, but it starts to act just like a metal. The pressure is so intense that it literally squeezes the electrons right off the hydrogen atoms, allowing them to flow freely. And that means it can conduct electricity. It is quite literally a flowing sea of liquid metal.
Down here, the pressure is millions of times what we feel on Earth's surface, and the temperature is a blistering 10,000 degrees Celsius. It's this flowing, electrically conductive sea of liquid metal that generates Jupiter's incredibly powerful magnetic field, and it makes up the vast majority of the entire planet. This is the real Jupiter.
So this brings us to the final and maybe the biggest mystery. You'd think, after all these discoveries, we'd have a pretty clear picture. But no. The Juno mission revealed one last completely baffling surprise right at the planet's center.
That old theory of a nice, solid, defined core of rock and metal? Totally wrong. Instead, what Juno found was a fuzzy core. It's not a distinct ball at all, but this massive, diluted soup where rock and metal are just mixed right in with the liquid metallic hydrogen. It stretches out for about half the planet's radius.
Which, of course, leads to the one question that is now driving planetary scientists crazy. How did its core ever get like this?
The most logical idea was a giant impact, right? Maybe a huge protoplanet, something like 10 times the size of Earth, just smashed into a young Jupiter and scattered its core everywhere. So astronomers ran computer simulations to test it out, and that's where the whole thing falls apart. While the collision did create a fuzzy core at first, in every single simulation, that fuzzy soup just resettled. Gravity pulled it all back together into a defined, solid ball. The theory just doesn't work.
And that's where we are now. For everything we've learned, we still don't really have a good answer for how a planet like Jupiter is even built. We've just replaced old, simple misconceptions with deeper, way more fascinating questions. It's a giant mystery in the sky just begging to be solved.